Could you just take just a minute each and let us know what it is that you do when you go into work in the morning? What is it that you do as it relates to storage?
So I've been in storage for 35 years, worked at EMC in the past, as well as IBM in the past. I'm back for a second stint, done 7 storage startups. I'm still working, even though I've done the startups, sold 5 of them. NetApp bought 1, EMC bought 1. Anyway, so I just live, eat, and breathe storage. That's what I do.
There you go.
Chip, for me, it's kind of interesting. I'm all about being a mission partner. So for me, it's not just about the technology, but it's about bringing capability into meeting mission environments, mostly tactical or anywhere in the world, really the mission that takes us. So for me, it's be about mission enablement just about every day.
Thank you.
And I guess for me, it's an interesting conversation because there aren't a good set of definitions on what a CTO does, especially a field CTO around storage. So you kind of have to make it up as you go. And part of it is technology evangelist, guidance counselor to the customers, and then at the same time, you have to be a good listener. Take all that feedback, bring it back into the corporate division, and then use that to build products and capabilities that help and solve the problems of the customers. So that's kind of my job.
Well, thank you for the 3 of you to being here. I'm looking forward to hearing from your expertise of it. I've been asked to moderate a panel, and the name of this has to do something to do with storage modernization. Now, storage is just, you take a bunch of data and you put it out there, and there are, of course, the regular technology increases that come every year. But outside of that, I mean, what's to modernize with storage? I'm just wondering, since each of the 3 of you agreed to be on this panel, that means you must have some idea what storage modernization means, just to put a different perspective on it. Could each of you take about 5 minutes and say, not just what storage modernization is, but for the people who are here today and the people that are streaming in later, what is it that, if you were going to say to them you need to modernize your infrastructure, what does that mean from a tangible sense?
So a couple things. First of all, every year in high tech is a dog year. So does anyone in this room have a 14-year-old iPhone? No, I didn't think so. So storage goes under the same thing. Storage is constantly evolving and is constantly changing. Same time, storage is that critical infrastructure underneath anything you do, whether you're doing cloud, whether you're doing traditional old-style workloads, modern databases that are NoSQL-based, the older databases that are SQL-based, cloud, big data, AI, it doesn't matter what. All data on this planet sits on storage. So if your storage isn't any good, your apps aren't any good, your workloads aren't any good, and by the way, God forbid your data goes away. All data on this planet except what's in your head, and most of it that's in your head might actually be also sitting on storage somewhere because you learned most of what's in your head. So it's very important to understand that if you don't constantly play with your storage, and storage is very underestimated. It has a huge impact on your reliability, on how your applications and workloads function, and really has a real, in this case, the government, but if you're talking more globally, government, business, education has a real impact on how your end users interact with your applications, your workloads, and your use cases. So already that storage modernization is critical. Storage modernization goes in cycles. So right now the hot cycles are hybrid cloudness, the NVMe protocol, which is a high-performance protocol. Also, how do you support new world applications like NoSQL databases, big data, and AI? So that's the current evolution of storage. But trust me, storage has evolved. About every 3 to 5 years, there's hot new things in storage. And so you need to be on that treadmill, on that cycle of refreshing. Because remember, a 3 to 5-year-old storage array is 21 years old to 35 years old. And you're not using a 21-year-old or a 35-year-old cell phone, trust me. So it's really important that you're modernizing your storage on a regular basis. If you want to save money, you want to save time, and you want to have your users have the best application workload and use case experience.
Cameron, what do you think?
Yeah, so for me, it's a little different. It comes above the abstraction of the hardware medium itself. Many years ago, we talked about being in the information age. I would advocate to you, we're kind of in this knowledge age, or this age of enlightenment. So for storage, the modernization really has to focus on information and knowledge management. That really is what drives and powers a lot of the missions. When you look at the mission environment today, it is global, right? It's not centralized in data centers. Information's being collected all over the world. Eric had mentioned things like artificial intelligence. You've also got IoT coming into the picture, right, which is creating storage at the tactical, or information at the tactical edge. So the real question becomes, what does my modern storage infrastructure look like to deal with the way that the mission is creating data and information today, number one. Number two, how do I software define that so that I have the ability to create a fluid storage pattern so I can create and move information closer to the algorithms I need to really start to gain knowledge and insight about what's going on in my mission segment of the mission space in the federal markets. So for us, it's not just about enterprise storage. It's about how do you take that type of information management forward into deployed, into tactical worlds, talk about converged and hyper-converged and the rise of how things are becoming more software-defined every single day in the world. So for us, the modernization really is a multi-layer, multifaceted approach, but it's all centered around the mission capability, and what that operational environment looks like.
Thank you. Kirk?
Yep. So I'd like to elevate the conversation just slightly beyond storage. I mean, you tend to place data or information on storage controllers and manage the controllers, but really it's about data management, right? And I make a statement here that data is going to be the new oil or the new currency of our environment moving forward. And you have to move into aspects where you do data management. I'll make a statement here that with storage, and we'll probably talk about drives and flash and the NVMe protocol and all those kind of things, but fundamentally what the underpinning technologies are giving us is a capability where we'll have limitless capacity and limitless performance. It's no longer do I have to find a controller that can run my database at rate or scale a storage solution that'll that'll store all my data. It's really a conversation about how do I take these limitless resources now, start to do orchestration and automation. How do I control my data? How do I manage my data? So I prefer to elevate the conversation and say it's about data management and not necessarily about storage. And so that's where I think the next innovations are going to occur.
So one of the things that we have an infinite amount of data, we have an infinite amount of storage, we don't have an infinite amount of money.
Correct.
So what that means is that we have to start being a little bit particular about the way that we choose to deploy this data in different locations. Now, over the years, we've come up with a number of different architectures that we've come up with direct attached, and we've come up with HCI, and then we've come up with IP Connect Network. It seems like we have a lot of choices today. And for a long time, when I was talking to purchasing agents, the choice for storage seemed to be whatever was the easiest to order. Right? So somebody would have something, and if it happened to be on this list that I was ordering, it was the responsibility of the people managing the applications to try to figure out how to make that storage work. But we still have a lot of different storage architectures. So my question to each one of you is, why are there so many storage architectures today, and is there a new storage architecture that's coming along as a result of modernization? Or do we just have so many because different people sell different things, or because they're easy to buy? Or can you come up with a profile to help people who are trying to figure out how do I modernize not only from a technology viewpoint, but from an architectural viewpoint? What's the right choice?
I mean, I'll take the first swing at it then. We'll go the opposite way.
There you go.
I get to talk first. So when you say types of storage, I really think you're inferring protocols, right? Is it iSCSI?
No more architectures than that.
Well, okay, but the architectures tend to imply some sort of connectivity profile, right? And then beyond that, where I think the evolution really needs to occur is we've been thinking of data services. Think of it as a request for capacity and performance combined. And in that scenario, you would make a request of your infrastructure that's largely software defined and say, I need 50 terabytes at 50 IOPS per terabyte stored. Now you have not only a capacity request, but you have a capacity request in conjunction with performance. I mean, that's how you buy services today in the cloud. And so the evolution needs to be, you start to consume and deliver storage on-prem much like you would buy from a hyperscaler. You don't care about what's in the background, right? It's not an architecture any longer. It's a storage service that may come in the form of an object. It may be a file. It may be a LUN. But the point is you request the storage, the protocol, the latency, and then the performance aspects of it in the form of IOPS per terabyte stored. And that's where we're headed out. And that gives rise to all RESTful interfaces into that. So I make a call into a software infrastructure saying I need this capability. The infrastructure or the software figures out the best resource to land that request on, and then from there you're off and running, right? And so it should operate just like it operates in the cloud. Do the same thing on-prem.
Yes, Chip, I'd complement that a little bit. I think, absolutely right direction, because that's what really software is beginning to create for us, is that abstraction layer to allow you to choose the best architecture that's optimally suited for whatever mission scenario you're encountering. As an example, the one scenario that everyone really gets I happen to use Chevy because I don't drive a Tesla. I can't afford a Tesla yet. But when you think of things in a tactical or mission environment, right? You choose an architecture that meets that scenario. You can't quite put a full frame in a Tesla, right? It's just not going to operate, although it's producing, 40 to 50 gigs of information every time it drives and all these types of things. It really is about what is the scenario you're trying to solve. You have enterprise architectures to deal with brick and mortar data centers, hyperscalers, the software layer with the data services on top are consistent. You've got architectures that deal with the base of 5G cell towers, right? Because we have 5G coming onto the market with advanced data and information management services. And you've got a tactical architecture, right? You have some environments, both civilian, DoD, and intelligence community, that require 1- and 2-man rules, right? Something that you can carry on your back and be able to go out and prosecute some sort of mission scenario. You have scenarios where we're using a lot of UAV, unmanned, and all kinds of things in the mission sets today that are bringing down streaming data and information. So you have to afford yourself a luxury to meet the mission or business objective and choose the proper architecture and data service to meet the mission outcome in the scenario you're in.
Eric.
So I think the big thing is about transparency and data mobility. So whether that architecture is the traditional SAN or NAS or object store, doesn't matter. The key thing is in a software-defined world, you can move data around transparently. And the applications look for the data. All of us have APIs. We have a product called Spectrum Discover, for example, on the file side, that any big data or analytic package or AI package can talk to the metadata. Okay, well, the users don't need to know that. And that happens to be a way where you're moving data around transparently, in this case, from the storage side into the application management side. And the idea here is it doesn't matter whether you're SAN or NAS or DAS, doesn't matter. And the whole point is that you move the data transparently, you keep it hidden, and the applications just talk to the storage through APIs, and all of us do that. And that's where the world is going. So that way you don't have to worry about SAN or NAS or DAS or this or that or Hinklemeyer, which will be the new architecture that comes out in 6 years. It won't matter. Because as long as you can move the data around, as long as it's transparent, as long as you can move things back and forth easily between the applications and the storage sets, then it doesn't really matter because it's all about transparency and data mobility, regardless of the architecture.
So there's still some situations where it seems to me, again, as the non-expert here, that if I'm getting into a self-driven car, I don't want to hear, well, it's just going to the right source and getting the right information and off it goes. If I'm going down the street at 60 miles an hour, I still want the feeling that there's predictability in what I'm putting into the system, and I'm going to want, selfishly enough for me, high performance I/O when it comes for me to gather the information to keep my car between the lines. So that seems to imply that part of modernization has to do with the fact that there's going to be a class of applications that are going to be available that weren't available before, because not only can we keep as much information as we want and we keep it wherever we want, but the fact that we can get to that information now more quickly than we have in the past. So I guess I'd like to take all three of your blush on that it seems like speed has to be part of this equation someplace. Like we can get a lot of inexpensive storage, we can get a lot of fast storage, we can get a lot of something else storage, but we always end up putting that qualifier on it, don't we? That I can't just walk into one of your environments and just say, I'm going to plop down this storage and it's just going to be there. At some point you're going to say to me, yeah, but will I finish my reports on time? Or will I be able to finish my reports with this budget? Still seems to me that there is a little bit of, we're not completely transparent yet. Could you talk about how modernization relates to that? How can we get to that point where we don't care anymore? And at that point, even though we're not seeing it, it seems there's still going to be a blend of different performance we have to do to sort of balance out that cost performance.
Yeah, so I'll take a swing at it, right? So maybe if we dig deeper into the RESTful API services, it'll be borne out. And typically, a RESTful request for a storage service or a data service or a data management service, even a higher level, will come with the rudimentary capabilities of capacity and latency. But there's almost always a SLA associated with that RESTful request, right? And so you will, as part of that RESTful interface, you will make a request for 4,000 IOPS a second, right? And so that service will, the new capabilities of most of the storage controllers that are out there today would do a rate limit for quality of service, right? It'll start at the top and decrement so that it kind of puts everyone into their buckets. The new way of doing storage is it's a storage guarantee. I will guarantee you at least 4,000 IOPS. I'll give you a max of 6,000 and I'll let you burst to 10,000 for 2 seconds, right? And that's all part of that RESTful call. The software works it all out. We're not landing on a particular product or a controller or a specific disk type in order to satisfy that. The software has an ability to adjust its service parameters as it goes through the software layers from the API interface down to the back-end infrastructure. And then fundamentally, you get the request, and you are guaranteed what you've just requested via that RESTful call.
Is it fair to say that you could also be denied? For example, if I make the RESTful API call into my tractor and say it goes 65, is the tractor going to come back and say, we're not going 65?
Well, I guess in theory, you would do that as well. I mean, you'll have a rate limit. You'll have that max, and it'll cap you at the max, right? And so, let me put it a different way. So the way we manage storage in NetApp is different and unique. We look for what I call flatlining of data services. And so we see all these calls coming in, and if you see flat lines, it means everybody's getting exactly what they've requested and are expecting, right? And so there's none of this sawtoothing of I'm hitting my min, I bounce up to my burst, and then I come back and I get rate limited back down to my max number. If you walk in and everything's flatlined, everybody's getting what they want and they're happy, right?
There you go.
If a system administrator comes in and he sees this guy that's sawtoothing up and down, that means there's a misconfiguration on the quality of service parameter. At that point, the administrator can come in and he can adjust the quality of service to satisfy a new SLA, or the application can re-request via the RESTful call a higher level of service. It's all done dynamically, right? We're not moving things around. You will change your max then, right? You'll see that you keep hitting and you get throttled back down to your max. You adjust your max and now you're flatlined again. And so the management of data and data services happens, kind of dynamically now, as opposed to moving these big chunks of volume around and trying to land them on a controller or a disk type.
Cameron, I saw you shaking your head.
Yeah, I mean, I'll compliment a little bit what Kirk's saying. I mean, everything's got to be in balance, right? Software, absolutely. We all keep hearing the overused expression, it's going to eat the world, but there is a balance at some point between how science finally just, the rubber hits the road, right? So it's a balance between the software and the underpinning hardware and some of the advancements you make there. We all work with NVMe, we all work with Flash, we all can get some of the more modern physical capabilities. For us, it's about looking where the constraints are in the backplane and removing those as well to complement what the software is doing. Because if it's one thing all of us who've worked with software know, software gets bugs, right? It gets bugs, it gets challenges. And to Kirk's point, I mean, not all programmers program perfect code, right? So at times you're going to have these other dynamics. So you have to have multiple layers of aspects built into your storage infrastructure and strategy that allow you to contend with these types of constraints and some of the things you're going to see at the software layer. So I think it's a balance. It's a balance of looking at that. For us, we're really leaning into how to remove the backplane constraints, right? The I/O that happens between CPU, shared memory, and what actually gets flushed to disk, and how do you start to move to be able to compute at clock speed a little better, right? How do you remove that constraint of the memory pool and maybe go from CPU directly to memory and then being able to be able to write directly to memory. So when you look at some of the advancements there, that's when you're getting next generational capability where you're removing some of the basic scientific constraints that we see today just on the hardware layers.
Two different views. What do you think, Eric?
So I think, again, it really comes down to 5 parameters that you look at when you make a buy decision. From a practical perspective, what are the applications? What are the use cases? What are the workloads? What are their priorities? All of us have software that automatically adjusts. All of us have quality of service guarantees. So you got to figure out what you want to do. You also have price points. All of us have expensive products, medium priced products, and entry products. And the entry products don't do as much as the high-end products, more expensive products do. But at the same time, you don't always need that. And for large shops, government or commercial, if you're a global bank or you're the biggest federal agency, you probably need high-end storage, mid-range storage, and entry storage based on your application workload and use case. And then the other parameter besides those and the budget, what can you afford to spend for what workload, application, use case? You need to prioritize that with the application owners and the real end users, because IT is really a service to the company or service to the agency. That's what you're really doing. So you got to go to the end, you say, oh, this app, for example, all these chairs here, they're in an asset database. Does that need to be on the fastest storage on the planet, the asset database? No, But does a high-performance database that's handling air traffic control? Like, heck yes, and it better never fail. The asset database, if that array fails the underlying infrastructure, so what? How many times do you need to look at all your physical assets, the whiteboards, the lights? But everybody tracks that, and you need to. So, and then the last thing is security. Anyone who thinks that security is just about buying security software is wrong. All of us have intense security that's in the storage. So if all you do is think about, I'm going to create the Great Wall of China to keep the bad guy out, I'm going to buy security software that chases the bad guy down. Everybody, every agency, every large enterprise on this planet is going to get broken into if you haven't already been broken into. And while they're in there, while you're chasing the guy down, they're stealing you blind. So if you don't encrypt the data, don't encrypt your backup, can't do things to prevent malware or ransomware that the storage guys do. If all you do is buy security software, you are not going to have a fully secure agency or enterprise or anything. So I think those 5 things, application workload and use case, prioritizing them, how much you can afford to pay based on those apps, and making sure you have the right security. Because everybody thinks, oh, I just go to the security software vendor. That is not going to keep you secure. If you don't include storage in your equation, you will not have a secure agency or a secure company or a secure university. You absolutely will not. You need storage to be secure as well, or you won't get the security you need.
Yeah, for those of you who are following along in the home program, there will be at least 2 more sessions on security. It is a hot topic this year, and I think a lot of people are drawing attention to it. Part of making a secure infrastructure, though, has to do with the way that we've automated those resources that are going to be testing our security for us. In the last session, we heard a little bit about automation. We heard about some of the things that are happening. I wonder, as it relates to automation, programming's been around for a long time. I mean, APIs have been around for a while, although the ubiquity of the REST interface is changing a lot of different things.
Right.
But that gives us the capability now to automate. Could each of you just spend a few minutes, as it relates to modernization, what the users can expect through not just features of infrastructure, but rather automation of infrastructures that's going to make their lives easier, and why they need to modernize to take advantage of that automation.
You want to do an inside out this time, guys?
Sure,
Yeah,
let's
there
go
you
for
go.
it.
Why not, right? You know, software defined has really changed a lot regarding automation. I mean, we all know that the software we use to manage our storage frames has been around for a long time, and for many years, you know, you had a spectrum of talent in your, you know, management staff. A lot of them could use scripts to do a lot of management and automation organically. Some of them couldn't. There were a lot of manual steps. Today, with software-defined automation, it's becoming extremely pervasive. The thing we're finding with a lot of government customers is the ability to be able to deal with the governance and then the compliance aspects of leveraging the automation. There is an incredible amount of automation available in all of the software that agencies own today. The challenge is the talent to be able to write the right workflows that meet the mission objective and the mission environment. The second is the management and maintenance, and then the third is a trust factor. But to take a point off the curve of what Eric said around our security, security really is around trust, right? And then trusting that the automation is doing exactly what we anticipate. I come back to the scenario you mentioned. If I'm driving a car at 65 miles an hour, I want to know where the data is, where the compute is, and where the application is. Because if a deer runs out in front of me, I want the car to stop, right? I don't want to know what I'm eating for dinner that night, right? I'm not going to hit the deer, and you know, it's those types of things. So I want to make sure that those things are working with trust. And that's the real aspect we have to improve to let people to more pervasively adopt the automation. But the capabilities there, and we're seeing a lot from a resiliency, mission resiliency, data protection, but more importantly, cyber recovery. You know, most people don't think about storage and the ability of cyber recovery. What do you do if you have a ransomware attack? You cannot bring the whole agency down. You have to look at your data protection, encryption, and look at a specific cyber recovery plan and bring a snapshot of that data or information back so that you can get your missions back online. So for us, it's a little bit of a balance.
Gentlemen?
Sure. So I think the big thing you've got to realize that is all about putting all of this together. Automation, every storage vendor you have, big, medium, or small, all has intense automation. Everything, whether it's moving data around out to the cloud, data between systems. For example, we have software at IBM that can move data to 450 different storage devices, most of which aren't ours. So we can move data to NetApp, to EMC, to HP, to the old Dell stuff before they bought EMC. We can move data anywhere you want, okay? And all of us can. And back and forth to the cloud, whether you're running a hybrid cloud config, whether you're, because of security you're running a private cloud, you're still moving the data around all the time. So automation is what keys that. Anyone who can tell me you have as many storage admins as you had in 2007 before the downturn, I applaud you, because no one else does. We can go to accounts all over the world in all segments, in all kinds of government agencies all over the world. If there was 100 people doing storage in 2007, right now with 10 times the capacity and 10 times the needs for performance and security, they have half the number of people doing it. How do they do it? Because it's all highly automated. So it's really, as pointed out, about the trust factor, because all of our software is heavily automated, because all the storage infrastructure people have dramatically declined in headcount across the world in any government, in any enterprise, in any educational institution. The amount of people who really run your storage and manage it has dropped by, I'd say, half, best case half. So how do you make up for that? You automate everything. So we all have it, and automation is critical. I think things like trust is the one area you guys have to figure out, because we just automate. We move it around. We have, what manager can do this, and we all have the ability of controlling who can move data around and who can make the decisions on our software. But you have to decide what you want to do with that and take advantage of the security that we put in from a management, role-based management security, which we all have in our software. You guys have to figure that out, of who you trust and who you don't trust.
Final thoughts?
Yep. How much time do I have?
You have about 4 minutes.
About 4 minutes. Okay, I'll tell you a little story then. So NetApp storage controllers have a capability to send what we call telemetry data back to our headquarters, and we've basically built a data lake over the past 25 years with all this telemetry information that's been streaming back. We would do batch analysis on that information and provide reports to our customers to show how well the storage has been is being operated, if they're at risk of data loss, predictive failure analysis, but it's a monthly kind of thing. As we move to the era where everything's programmatically controlled and you have API interfaces to it, we wanted to take another step beyond that. And yeah, sure, you can write more scripts and kind of automate things, but we wanted to start to use AI as an ability to manage our information. And so we now have an active IQ service that uses AI on the back end. And so envision, if you have these programmatically controlled assets now, you can have an AI bot that sits on the back end of your systems. It notices that you have a volume, it's highly, highly utilized, and by the way, that volume has no data protection associated with it. No backup has been run, there's no snapshots on it. What do you do for it? This AI engine can actually invoke a method out in the cloud to do a backup of that volume just in case that storage controller or that volume goes offline. And there's a whole bunch of other opportunities where you can start to apply these AI techniques to data management and storage management. And I think it gets a lot of that orchestration and automation stuff out of the way. It removes the programmer and the application guy trying to write stuff, and you can start to use bot services in order to manage your data. And I think that's really where the future's headed.
That's excellent. It's obvious that these gentlemen have a lot of experience, and one of the things that they can offer is that they spend a lot of time, I assume, not only in the federal space, but also talking to the commercial market.
Oh, absolutely.
There's going to be another session that's going to be held this afternoon. David Schmeichel is going to be moderating that, and we're going to be talking about how to take some of this expertise that you've heard on this panel, and how do we bring in some of the lessons that we've learned outside in the commercial space and find out how that can apply to what you're doing. Because it turns out in that space there's a lot of, I guess the healthy way to say it is competition. Is that a fair way to put it?
Sure.
But that competition has driven innovation, and these three gentlemen here are to tell you what some of that innovation is. So hopefully you'll have a chance to either talk to these gentlemen at one of the breakouts, or you're going to make it to the moderated panel later on. Thanks for coming today. I really appreciate this. Hopefully this has been helpful. The next session up is going to be David Schmeichel, who's going to be talking to us a little bit, focusing more on this issue of automation as it relates to your infrastructure. Thank you very much.